ओके, तो ये जो मैं केस आ गया था T1 इज ग्रेटर देन T2 बिकॉज टेंशन हाई टेंशन इज more tensile force compared to the loose tight center. So when this condition, when T1 is greater than T2 and when A is greater than B, such conditions, तभी जाके ये इक्वेशंस फुलफिल होता है, ये इक्वेशंस फुलफिल होगा, दिस इक्वेशन फुलफिल होगा. सेकंड केस हम ले लेते हैं कि when the rotations clockwise. Okay, in this case the tight and the slack sides are reversed. Okay, reversed. How? Suppose that because the rotations is a clockwise direction, because it's a clockwise direction, so this direction is parallel to this rope, but this is a anti of this rope. So this belt side is become tight side and this become is the loose side. So now the figures of this mechanism changed. All the parameters will be the same, but only the tension side and loose side will be changed. Okay, so now I am drawing here same, all the parameters will be the same. Okay, so here this is our lever. Okay, this is lever, this is a fulcrum. So this is our become the tight side and this is become the loose side. So just we draw our cylindrical drum. Should be the passed over the, this is a cylindrical drum with radius r and this is our belt, this is the center. So now when this, okay, this, the case is here, just simply this force is downward directions. This is center, this is our radius, maybe the angle of contact theta. Okay, and this is the effective radius of the cylindrical drums. So in this case now we're taking the moment about from this pivot point, and when this is A from here to here and here to B, and this is total length L. Okay, is the length from free end of the lever to the pivot point. In A is another free point of lever to the fulcrum, and then fulcrum to the belt joint point. So when it is a clockwise directions, so this become the tight center, tight tension. So this is a T1 and this is become the T2 is a loose center. So then again taking the moment of this force about this point, then what will happen here? The taking moment. Okay, the taking moment about the pivot O. So what will be that? Simply that force is downward direction, so you scale it clockwise directions for this point. Okay, this is a force this direction. So then FL. Okay, this clockwise direction. Force into perpendicular distance FL. Then T2 is here to try to anti-clockwise direction, the negative T2, and the T1 is about this point is try to clockwise direction. Then T1 AB equal to 0. So then the magnitude of the F is here T2A by T1 B1 by L. So in this case, because we know that the tight side is always greater than the loose side. So here we know that, as we know that here, as we know that, as we know that T1 is greater than T2. Okay, because T1 by T2 E by this is the coefficient of frictions between the belt and the drum, and this is the contact theta between the belt and the drum, which is at the center theta. Okay, in previous class or discuss about these equations. So now when T1 is greater than T2, so then obviously T1 is greater by should be the positive. So should be that positive. So how can we substitute it positive? So if in the case here the BA is always greater than B, so now here A is greater than B. Okay, so the value, this F should be the greater and positive, so therefore T2A should be greater than this part. So for because F is a positive, so therefore T2A is greater than T1A B. Okay, this equation have taken from these equations. So now we can write here T2 by T1 obviously greater than, so just to T2 by T1, that is B by A. Okay, so we have B, just have changed these equations. So as long as the ratio of T2 by T1 is greater than the ratio B by A, so in this case, if term will be greater, the T2 should be the greater than T1, then it's possible when the B by A is greater, is less than this value. So when suppose that this possibility is 0, so when T2 by T1 is if equal to A by B, if this equations here equal to greater than this AB by this, so that then possible, then the F is 0. F is 0 when T2 by T1 is equal to A by B. Okay, sometimes it's just like a T1 by T2, and F is a negative, maybe when then this value is greater than large. So overload, this become is a, when the F is a 0, then this become that self-locking braking systems. So the brake becomes the self-locking, as no force is needed to apply the brake, and once the brake has been engaged, no further force is required to stop the rotation of the drum. So finally, this conclusion we have added here depends on the effectiveness of the force is obviously depends on that this three statement here I have written here: the direction of the rotation of the drum, ratio of the A and B, and the direction of the applied force. So this is first case. Second case I have taken here, when the first case is when A is greater than B, and when F is act on the downward directions. Okay, and but rotations is anti-clockwise and clockwise direction. So I have got it the effectiveness of the forces, means the force may be the self-locking, brake may be the self-energy brake. It depends on the rotations and direction. Now the second case I am here, just all the things will be changed here when A is greater than B. So now when the second case, when A is greater than B, the case 2. Okay, because the ratio of the A and B and direction of the force, okay, and direction of the applied the force and direction of rotation of the drum. So when A is B, the third case, is suppose that ki A and B, if B is greater than A, and F is F is upward directions. Okay, this is the case. Now just draw the mechanism of the band brake about these conditions. It is a continuous lever, it is a free end, and this end for supporting rope, and this is a fulcrum. Okay, so just draw the cylinder, and the belt is passed over the cylinder. And this is center, and suppose that this is a angle of contact theta, and this effective radius of the drum r. Suppose now when the force is applied is upward directions f magnitude, and this is the length of the force is L, and this is we taking about A, and this is B. So all the parameters are same here. Okay, but assumption that the B is greater than A, and when F is applied for upward directions, then what is the effectiveness of the force on this drum? Okay, means the brake has been engaged. Suppose that the brake has been engaged, so no further force is required to stop the rotation of the drum, or maybe if the brake has engaged, so there is more force is required to stop the rotation of the drum. So these are all the conditions based on the mechanism. So suppose there is first case is when the is rotating is clockwise directions, anti-clockwise directions. So if is rotating is anti-clockwise directions, it's the first case when the drum is rotating in the anti-clockwise direction, and such mechanism I have the draw here. तो अगर ऐसा होता है तो क्या हो सकता है, इस पॉसिबिलिटी का क्या हो सकता है, और सपोज एफ इज अपवर्ड डायरेक्शंस. ओके, तो जस्ट सिंपली भी एक पिवोट पॉइंट यहाँ मान लेते हैं, तो हम मोमेंट ले लेते हैं. तो टेकिंग मोमेंट अबाउट पिवोट पॉइंट ओ, तो ये पेन है यहाँ पे, ये अपवर्ड की तरफ जाएगा, तो एफ इंटू एल. ओके, second case this is our rotating, so this is a loose side T2 and this is our tight side T1. Okay, so then सोच के बताओ तो यहाँ पे क्या क्या लग सकता है मेरा है, यहाँ पे क्या होना चाहिए. Just think, maybe anti-clockwise, clockwise, anti-clockwise. Therefore TA minus T2B equal to 0. So F will be here T2BB minus T1A by L. So as T2 is greater than T1 and B is greater than A, then brake is operative only when T2 is greater, T2B is greater than T1F, because positive यहाँ पे होना चाहिए मेरा, या T2 by T1 is this conditions. Again we will similar things. Okay.